In today's note, we are going to look at exponent rules. Now, you may have looked at some of these before, but we are going to look at them again. But basically, just as a general review, an exponent is basically a base number and the exponent or a power. So what this is, 2 to the power of 3, basically means it's 2 times itself 3 times. So we can see over here that that solution is 8, because 2 times 2 times 2 equals 8. So the base number represents what's being multiplied multiple times, and the exponent tells us how many. So what we want to do in part 1 is write each product as a power. So in this case, we see that 3 is being multiplied multiple times. So 3 is going to be my base. And then how many times it's multiplied is going to be my exponent. So in this case, there's 4 of them, so it's going to be 3 to the power of 4. For b, we can see, even though there's no multiplied sign, when we see two things in brackets next to each other, that means that it is multiplication as our operation. So I see that I have -2 being multiplied multiple times, so -2 is going to be my base. And then because it's being multiplied 5 times, that's going to be my exponent. One thing to be aware of, if there are brackets around the numbers that are being multiplied, include that in your power or exponent. So because the -2 is in brackets, we have to include that when we write our power. For 2, what we're going to do is evaluate each power now. So we're going to be using our calculator to just figure out what these work out to. And this may be different, or the button may be different on every calculator. It may be, say, something, you're going to do 3, and then it could be something like a YX button. It could be a hat or a little triangle. It could also be something like X with a box, right? You could have multiple options. So you're going to hit basically 3, and then that one of these options, again, let me redraw that one. So it's more of an arrow, not an N, depending on your calculator. And then after that, you're hitting your exponent. So in this case, it will be 4. So you're going to do this for all of them, but if we do 3 to the power of 4, we should get 81. Here, -2 to the power of 5, what we want to do, again, enter it as we see it. So -2 in brackets to the power of 5 is -32. 1/4 to the power of 3. So when we have a fraction, what we can do is each part of the fraction has that exponent added onto it. So 1 to the power of 3 and 4 to the power of 3. And I can simplify this to be 1 over 4 to the power of 3, which is 64. So if you need to get exact values, or when we're asked to evaluate, this is how we should be doing it. If we were to enter in 1 over 4 to the power of 3, depending on your calculator, you may just get a decimal. But it is helpful just to keep it as a nice fraction by applying that exponent to each part of my fraction. D, -2 to the power of 4. Again, same thing that we've been doing, -2 to the power of 4, and we should get 16. E is -2 to the power of 4 as well, but the difference here is that I don't have brackets around the entire thing. So what this actually means is -2 times 2 times 2 times 2. So that negative is not included in the bracket, or with the exponent. So what we do get when we do this is -16. Because that negative is not included, it's 2 to the power of 4, and that negative is out front. So that's why it's important to enter it as you see it. So in this case, there are no brackets, so we're not going to include it. If we go back to D, there are brackets, so we do need to include those brackets. Depending on your calculator, it may not matter, but in most cases you should be putting those brackets in. For f, same idea. Right? We have a fraction and a negative. The negative's in the bracket, so it has to be included. And with the fraction, I can apply, say, that power of 4 to both parts. Because it's a negative fraction, that means only one of those values is going to have the negative attached to it. I'm going to put it on 1 just to make it a little bit easier. But when I simplify this then, each part has the exponent of 4. So we end up with 1 over 625. So again, we're making sure that we're using kind of our understanding of exponents to come up with an exact fraction and not a decimal. So that's just a general review of powers on their own. What we're going to look at is what happens when we come across some situations. So the first one is multiplying powers with the same base. And what we do when we multiply powers with the same base is we add exponents and leave the base the same. So what we want to do here is we want to write them as a single power and then evaluate or get an answer. So in this case, we are multiplying two powers. They have the same base of 3. So my rule is telling me to add the exponents and leave the base the same. So if my base is going to stay the same, it's going to stay as 3. And if I add the exponents, I get 2 plus 4, or 3 to the power of 6. Then if I want to evaluate that, I can plug that into my calculator. 3 to the power of 6 is 729. And that's basically this question answered. B, same idea. I have two powers with the same base. They're being multiplied. So it would be 2 to the power of 6 plus 5. We add those exponents. Or 2 to the power of 11 as a single power. And then if we want to evaluate them, again, this is just entering into a calculator. 2 to the power of 11 equals 2048. C, again, two powers with the same base, so I know the base is going to be 9. The exponents, I have to add them. I know one's going to be 3. The other one I don't see. And if I don't see an exponent, I have to assume it's 1. So no exponent means 1. So you have an exponent of 1. So that means it's going to be 3 plus 1, or 9 to the power of 4 as a single power, and then evaluated 6,561. D, again, same thing. Here we have something in brackets, so that entire thing is going to be our base. So -4 in brackets is going to be our base. Our exponents, we add them because we're multiplying our two powers. So 3 plus 7 equals -4 to the power of 10. And then again, just on our calculator, we can evaluate. 1,048,576 is our evaluation. So that's multiplying powers with the same base. The next part is we're going to look at dividing powers with the same base. And if we divide powers with the same base, what we have to do is subtract the exponents. And the same thing as the last one, we're going to leave the base the same. So the key thing here is we're subtracting exponents. We're going to go through the same steps. We want to write each as a single power and then evaluate. So 5 to the power of 6 divided by 5 to the power of 2. Two powers that have the same base. So I know I'm going to have a base of 5. But now I have to subtract the exponents. So it's going to be 6 minus, so 5, write it a little bigger, 5 to the power of 6 minus 2. Or 5 to the power of 4. And then if we simplify that, or sorry, not simplify, evaluate on our calculator, 625. B, it's the same idea. Negative 2 is going to be my base, because that's the same base in both these powers. For B, or sorry, for our exponent, we have to subtract them because we are dividing. So it's going to be 8 minus 3. So negative 2 to the power of 5 is my single power. And then if I want to evaluate that, enter it in on the calculator. Again, remember, include those brackets. And we end up with negative 32 as our evaluation. C is the same thing. 14 is our base to the power of 7 minus 6, or 14 to the power of 1. If I wanted to, I can just remove that 1. I don't need to show it. I'm going to put it there just so we know that that's our single power. And then 14 to the power of 1 is just 14. D, even though I have fractions, it's still going to be the same steps. My fraction is my single base, so I know it's going to be 1 over 8. And to get the exponent, it's going to be 4 minus, I don't see anything on the bottom part, or my denominator of this bottom 8 over 1, or 1 over 8. So if I don't see an exponent, remember we assume that it's 1. So when I try to simplify this as a single power, it's going to be 1 over 8 to the power of 4 minus 1, or 1 over 8 to the power of 3. So if I want to simplify this, that means it's 1 to the power of 3 over 8 to the power of 3, because that exponent applies to both the numerator and the denominator. So this simplifies to 1 over 8 to the power of 3, or 1 over 512 is my evaluation. The third situation is going to be power to a power. And when I have a power to a power, I'm going to multiply exponents and leave the same base. So if I look at A, 3 to the power of 2 to the power of 4. So if I have a power to a power, this is what it's going to look like. I'm going to leave the base, and my exponent is going to be 2 times 4, or 3 to the power of 8. As a single power, again, we're just plugging this into our calculator. 6,561. For B, exact same thing. 2 to the power of 5 to the power of 3. 2 is going to be my base. My exponent is going to be 5 times 3. So 2 to the power of 15. And then evaluated as a single number, I get 4,096. C, again, is the same thing as what we've been doing. We have brackets, so we do need to include that. So negative 4 to the power of 3 to the power of 2. So if I want to simplify that as a single power, negative 4 to the power of 3 times 2, or negative 4 to the power of 6. Again, make sure we're including those brackets. And then to evaluate, just entering it on a calculator, we get 4,096 as well. So those are our 3 rules that we're going to look at today. And again, just to summarize them, if we're multiplying powers, we add the exponents. If we're dividing powers, we subtract the exponents. And if it's a power to a power, we multiply exponents. So those are the 3 rules that we kind of just have to remember. And it's going to help us if we ever have to do operations with exponents. So we're going to look at some practice. So we want to write these as a single power and then evaluate. So exactly what we've been doing. 5 to the power of 2 times 5 to the power of 4. So this is multiplying powers. So it's going to be adding exponents. So 5 to the power of 2 plus 4. 5 to the power of 6. And if I want to evaluate this, 1,500 or 15,625. B, we're dividing exponents, so I'm going to subtract, dividing power, so I'm going to subtract my exponents. So 6 minus 4 is going to end up being 4 to the power of 2, which simplifies to 16. C, 2 to the power of 7 to the power of 2. This is a power to a power, so I need to multiply my exponents. So it's going to end up being 2 to the power of 7 times 2, or 14. And then evaluate it as a single power, 16,384. D, even though I have fractions, it's still going to be the same thing. It's a power multiplied by a power. They have the same base. So I'm going to end up with negative 3 over 4 to the power of, because it's multiplying, I need to add my exponents, so 2 plus 4, which is 6. So that's it as a single power. If I want to evaluate it, that power of 6 goes to both parts. So negative 3 to the power of 6 and 4 to the power of 6. Evaluated, I end up with 729 over 4 to the power of 6, 4,096. So again, even with fractions, the same rules apply as long as the bases are the same. E, negative 5 to the power of 199 divided by negative 5 to the power of 195. So it looks very difficult because we have really big exponents, but we can simplify it to a simple power. We're going to subtract our exponents because we're dividing, keep the same base. When we subtract, we end up with 4. Then to evaluate that as a single power, again, just entering it onto a calculator, make sure you're including the negative in the bracket, and you should get 625. F, again, multiplying powers, so we're adding exponents. If we don't see an exponent, we assume it's 1. So 3 to the power of 6 plus 1, or 7. And then evaluated, 2,187. G, power to a power again. So we multiply our exponents. Negative 2, make sure you include that bracket. 3 times 3 is 9, so that's our single power. Then to evaluate it, again, just entering it on our calculator, you should get negative 512. H is dividing again. So if we divide powers, we have to subtract our exponents. So 5 over 7 to the power of 5 minus 2, or 3. If we want to evaluate this, then that exponent of 3 is going to go to both the top and the bottom. So 5 to the power of 3 is 125 divided by 7 to the power of 3, which is 343. So that is our single power. Again, if we're asked to evaluate, leave it as a fraction, or evaluate it as a fraction. Do not turn it into a decimal. But on any assignment, I'll make sure that that's stated. The last thing we're going to look at is when we have multiple values or variables. And when this occurs, what we want to do is focus on like terms. So we're only going to focus on the like terms and then apply our powers, or power rules. Remember, those power rules only work if we have the same base. So if we have a different base, then we can't use those power rules. So that's why we're focusing only on the like terms or on the same bases. So if I look at A, 4x cubed divided by 2x squared. So what I'm going to do in the first couple ones is I'm going to highlight the like terms, and then we're going to apply the rules after. So here, the two like parts are just our numbers, and then the second part are the powers with x, with a base x. So if I want to focus on the like parts, I can do 4 divided by 2. Those are just two numbers. I can divide them. So 4 divided by 2 is 2. We'll keep everything color-coded, so that's where that 2 came from. With the x cubed divided by x squared, they both have the same base of x, so I'm going to apply my power rule for when I divide. So in this case, when I divide exponents, I have to subtract. So 3 minus 2 is x to the power of 1, or just x. And that's where that part comes in. And that's as far as I can go. I've taken care of my operation, and I've put it down into a single power. For b, here we have a to the power of 4 x squared times a x to the power of 5. Again, focusing on the like parts, I can see that I have a's and I have x's. Both of the powers are being multiplied, so what I have to do is just focus on the like parts. So because I'm going to focus on my a's first, because I'm multiplying powers, that means I have to add the exponents. So in this case, 4 plus 1, because again, if we don't see the power, we assume that it's a 1. So 4 plus 1 is 5, and that's my first part. The next part, I'm going to focus on my x's. So again, power times a power, so I'm going to add my exponents. 2 plus 5 is 7, and that's the second part. So in this case, it's just a to the power of 5, x to the power of 7. And it's all one term, right? They're all just, it's not plus or minus in between, it's just one term. C, again, same idea. I have something in the brackets, and it's all to the power of 2. That power of 2 applies to everything in the bracket. So it's actually 3 to the power of 2 times y cubed to the power of 2. So when I simplify this, 3 to the power of 2 is 9, and I know my power rules for a power to a power. I have to multiply my exponents, so 3 times 2, which is 6. So if I can simplify a number or come up with an exact value, I can evaluate that, and then I can use my power rules for the rest. For D is the same thing, right? We have x squared y cubed all to the power of 5. So this exponent of 5 is going to apply to both the x part and the y part. So in this case, you could think of it as x squared to the power of 5, y cubed to the power of 5. Our power to a power rule says that I have to multiply my exponents. So x to the power of 2 times 5, or 10, y to the power of 3 times 5, or 15. I can't simplify this any further. It's only one term. I've gotten it down to a single power as much as possible. I can't do anything between these two because they're not the same base. X is a different base from y. E is another example of dividing with multiple variables. So again, I'm going to focus on my like parts. So the a's and the b's. Because I'm dividing, I'm going to use my power rule for dividing, which says I have to subtract the exponents. So in this case, a to the power of 20 divided by a to the power of 10. Subtract those exponents. 20 minus 10 is 10. And there's my first part. The second part focuses on the b's. So again, division of powers means I have to subtract the exponents. So it's going to be b to the power of 15 minus 5, or 10. And there's the second part. Finally, for F, the last example, here I have two numbers, or two things being multiplied. 2x to the power of 4 times 3x. I'm going to focus again on the like parts. In the like parts, first we have just our plain numbers. And then secondly, we have our x's. So I can multiply those two numbers. I can multiply 2 by 3 and get 6. And I can multiply x to the power of 4 by x, use my power rules for multiplying, and I add my exponents. Again, because I don't see anything on that x, I assume that it's 1. So I get 6x to the power of 5. So again, the main thing that we should be getting from this, if we go back up, are these three exponent rules. These are the three rules that we should be getting. And that's basically, again, just how we can simplify things, simplify equations or operations when we deal with powers. So again, just remember, multiply powers, we add the exponents. Divide the powers, we subtract the exponents. And power to a power, we multiply the exponents. Again, the key thing as well, make sure they have the same base. If they have a different base, it doesn't count. Or you can't, these power rules or exponent rules do not apply.